Good. So today we are going to do examples on numerical integration. So let's start by example 1. So use trapezoidal rule to evaluate. Start with just a simple function 0 to 1 x power 4 dx using, so the first case, n equals to 4, and then 2, n equals to 8. Then compare the truncation error in these two cases. Good. So solution. So remember we have the integral a to b. When we have integral of this form, then trapezoidal rule is given by this. Where h is given by b minus a over n. So that's the starting point. So let's now get our h. So h will be given by 1 minus 0 over n is 4. So it will be 1 over 4. So therefore now we have x and then f. So we have 0. We have a quarter, have 2 quarters, have 3 quarters, then we have 4 quarters. So when x is 0, so remember this is a function, f of x equals to x power 4. So 0, y will be 0. And then when it is 1 over 4, it will be 1 over 4, then power 4, so we'll have 1 over 256. Next one, we have a half power 4, so we have 1 over 16. And then next one, we have this one raised power have 81 over 256. And then 1 just the same as 1. So this is the same as our f0, f1, f2, f3, f4. So therefore we say the integral 0 to 1 of x power 4 dx will be given by h, which is 1 over 4, divided by 2, so just be 1 over 8, into f0 plus f4 plus 2 into f1 plus f2 plus f3. So we have 1 over 8 into 0 plus 1 plus 2 into 1 over 256 plus 1 over 16 plus 81 over 256. Now when you work out this one, you should get 0.2207031. And then so exact value, because this is a simple integral, x power 4 dx will be given by x power 5 over 5 from 0 to 1. So this just be same as 1 over 5, which is the same as 0.2. So therefore error will be 0.2 minus 0.227031. And then the percentage error will be given by this error over the true value, which is 0.2 times 100%. So this roughly 10.4%. Please work out and then confirm. So when you use N4, the error is 10.4%. Now when N is 8, you mean that B minus A over N, which is H, will be given by 1 minus 0 over 8, which is 1 over 8. So therefore we have X values and F values. So we have 0, we have 1 over 8, we have 2 over 8, we have 3 over 8, we have 4 over 8, we have 5 over 8, we have 6 over 8, we have 7 over 8, we have 8 over 8, which are the same as 1. So stop there. So 0 is 0. 1 over 8 is given by 1 over 4096. And then 2 over 8, 1 over 256. And then next is 81 over 4096. Please confirm these values. 1 over 16. 625 over 4096. 81 over 256. 2401 over 4096. And then this one will be given by 1. And then by definition, integral from 0 to 1 of x power 4 dx will be given by h over 2 into, let me just write as a gentle one. So from A to B of f of x, f naught plus f8, because now you see we'll have this will be our f naught, f1, f2, f3, f4, f5, f6, f7, f8, then plus 2 into f1 plus f2 plus f3 plus f4 plus f5 plus f6 plus f7. So therefore now we have integral from 0 to 1 of x power 4 dx. Our h is 1 over 8, so it will be now 1 over 16. So into brackets 0 plus 1 plus 2 into 1 over 4096 plus 1 over 256 plus 81 over 4096 plus 1 over 16 plus 625 over 4096 plus 81 over 256 plus 2401 over 4096. Now when you work out this one, the answer should be 0.2052000. Now you also get the error. The true value is 0.2 minus this value. And then percentage error would be this error over the true value times 100%. And the value we get will be 2.6 roughly. So comparing, we see that now when n is 8, we have a smaller error percentage compared to when n is 4. I remember the smaller the percentage of the error, the better the approximation. So therefore, we get a better approximation when n is large. So similarly, you can do as many problems on trapezoidal rule as possible. So next, will do examples on Simpson's rule. Thank you.